Okay, question 5 says the region E lies above the paraboloid z equals 1 minus x squared minus y squared within the cylinder x squared plus y squared equals 1 and below the plane z equals 2. Suppose that the mass density at a point in E is proportional to its distance from the z-axis. Find the total mass of E. Okay, so let's first go ahead and sketch a picture of the region E. And so I'll start by looking at the graph of the paraboloid. It's z equals 1 minus x squared minus y squared. So now we know that the paraboloid z is x squared plus y squared is just our circular paraboloid opening up along the positive z-axis. So if I do 1 minus, and think about this as minus the quantity x squared plus y squared, think about turning that paraboloid upside down and then shifting it up 1 unit. So in other words, we're looking at this right here. Now the cylinder x squared plus y squared equals 1. Think about just taking the unit circle in the xy plane, and then since this equation is independent of z, we're just going to be copying that unit circle as we run along the z-axis. And so in other words, we're looking at this cylinder right here. And so the other surface here is z equals 2. It's just a plane parallel to the xy plane shifted up 2 units. And so I'll put that in up there. And so now, where is the region E? Well, it's the stuff above the blue paraboloid, within this green cylinder, and below this red plane. So in other words, we're looking at this stuff in here. Okay, so now let's go ahead and talk about setting up our integral. So for the total mass, so the mass of our solid E, we know is going to be the triple integral over our region E of our mass density function. And I'll call that delta. So delta of x, y, z dv. All right, and now let's go ahead and set this up as an iterated integral using cylindrical coordinates. Now, if I'm going to use cylindrical coordinates, I'm going to go ahead and convert these surface equations into their corresponding cylindrical equations. So 1 minus x squared minus y squared, well, that would just be 1 minus r squared, since since x squared plus y squared is r squared in cylindrical. X squared plus y squared is 1, that would just be r equals 1. Because, well, really I'll say r squared is 1, but then taking roots, r is 1. Okay, so that's our cylinder. And then z equals 2 is just z equals 2 in cylindrical. All right, so now to go ahead and set up the bounds, if we let z vary first, well, we're going to think about r and theta being fixed, and then we're going to let z vary from the height on the blue paraboloid, so this would be z is 1 minus r squared, up to this plane when z is 2. So I'm going to go ahead and set this up, and I want to make just a little more space here. I'm going to get this. So I'm going to integrate, and I'm going to leave a little space here for my density function. So for the z bounds, we're letting z go from 1 minus r squared up to 2. All right, and then let's think about the region in which r and theta can vary through. So if I project my solid down onto the xy plane, well, I'm just going to cover the unit disk down here, centered at the origin. So these are our bounds then for r and theta. Not too bad. So r there will go from 0 to 1 because it's the unit disk. And then we're integrating over the entire disk, so 0 to 2 pi for theta. And I have my dr d theta. And as usual, don't forget the factor of r there. All right, and now we're just about there. The last thing we need to do is fill in our mass density function, right? And what we're told in the problem is that the mass density at a point E at a point any is proportional to its distance from the z-axis. Okay, so what exactly is that saying? Well, the distance from the z-axis is really just our radial distance r, okay? And if we're going to be proportional uh, to that distance, right, for our mass density, that means our density function, which would depend just on that radial distance, would equal some constant k times the radial distance r. So this right here would be our density function. And so I'll go ahead and put that in right here. We're going to have k times r. All right, so now in essence, what are we integrating? Well, the k is constant, just a proportionality constant, and we have an r squared there. And for the z integral, right, r squared is constant, so we're just going to get the difference then between the height of the plane and the height on the paraboloid, so it'd be just 2 minus that. And then the rest of it's pretty straightforward calculation. So I'm going to go ahead and put up the rest of the solution here. It's just a calculation. You may want to pause the video and work through the calculation on your own just to check your work. But here you go. So there is the rest of the calculation, and the total mass of the solid is 16 pi k over 15. All right, that's going to do it. Thanks.